Hi, everybody. It's Professor Mitchell. We're starting a new chapter today, Chapter 4 on solving systems of linear equations. So we'll start in section 4.1, which is solving systems of linear equations by graphing. So this is the first of three different methods that we will use to solve systems of linear equations. In this section, we will determine if an ordered pair is a solution of a system of linear equations. We'll solve a system of linear equations by graphing. And then without graphing, we will determine the number of solutions of a system. And in most of this chapter, we're going to be working on SLO-B, solving linear systems, okay? So as usual, there are some other terms in the SLO that do not apply in this chapter. All right, so when we talk about we already know what a linear equation is. A system of linear equations is a group of two or more linear equations. And when we talk about a solution of a system of two equations and two variables, which is the kind of system that we will talk about in this course, that is an ordered pair of numbers that is a solution of both equations in the system. So for example, let's determine whether each ordered pair is a solution of this system of linear equations, 2x minus 3y equals 8 and x minus 2y equals 6. The first ordered pair is -2, -4. The second one is 7, 2. So I'm going to switch over to the tablet. All right, so let's start with -2, -4. Remember that in order for the ordered pair to be a solution of the system, it has to be a solution of both equations. So let's start with 2x minus 3y equals 8, which I don't know what happened there. I'm going to write like this. Jeez. Okay, so when I put in -2 for x and -4 for y, and I put a question mark here, I end up with -4 plus 12, which is equal to 8. Okay. So for that one equation, the answer is yes. Okay, but it still has to work in the other equation. So now we take the other equation, which is x minus 2y equals 6. And we'll put in -2 for x and -4 for y. And that, and let's put the question mark, drop the fence. Okay, that gives me -2 plus 8, which is 6. So since it worked in both equations, the answer is yes. It has to work in both. All right, so let's try 7, 2, starting with 2x minus 3y equals 8. I'll put in 7 for x and 2 for y, question mark. All right, so that gives me 14 minus 6, which is 8. So far, so good. And now x minus 2y equals 6. I put in 7 for x and 2 for y. Uh-oh. 7 minus 4 is not equal to 6, it's equal to 3. So the answer for this system is no. So yes means it worked in every single equation. No means that there was at least one equation it didn't work for. And in the case of letter B, it was just the one equation. Of course, sometimes the ordered pair won't work in either equation. All right, back to the presentation. Oh, no, not back to the presentation. What I wanted to show you, even though it didn't say this in the instructions, I want to show you what it looks like when I graph those two equations, because that's the topic of this section, is solving systems by graphing. So I'll start with 2x minus 3y equals 8. And so remember in the last chapter, we talked about three methods for graphing linear equations. We talked about the point plotting method. We talked about using the intercepts, and we talked about using the slope and y-intercept. Well, usually my least favorite of those three methods is the point plotting method. However, I am going to use it for this first equation because I want to show you a trick that I've never told you about before. Sometimes students tell me they have trouble figuring out what numbers to put in for X and what numbers to put in for Y. And that is never more true than when the equation is written in standard form like this, AX plus BY equals C. All right, so here is the trick. When you're trying, and this trick will normally help you avoid getting fractions as any of your coordinates. So notice that the coefficient on X is a 2. So the trick is to pick multiples of 2 to put into the other variable, in this case, Y. Okay. So what I'm going to try for this one is using Y equals 0, 2, and 4. Similarly, if I had wanted to pick out values of X ahead of time, it might have worked out well to pick X values that were multiples of 3. This method doesn't always work, but it works often enough that it's worth knowing about. And of course, if you're doing this on paper, especially, there's nothing wrong with fraction coordinates. It's just, most people would rather avoid them. Okay, so I don't want to run out of room on my screen here. So, oh, wait a minute. Sorry, let me try that again. Okay, so putting in 0 for Y, we need to solve for X. So 2x minus 3 times 0 equals 8. Gives me 2x equals 8, which means X equals 4. So I put a 4 there. Now I do Y equals 2. 2x minus 3 times 2 equals 8. 2x minus 6 equals 8, which means 2x equals 14. I added 6 to both sides. That gives me X equals 7. Okay, now I'm just a little worried here about one thing. I think when I put in Y equals 4, I am going to get something that's off the grid. So I changed my mind. I'm not going to use 4. I'm going to use -2. I had said multiples of 2, and -2 is a perfectly good multiple of 2. Okay, I guess I'll squeeze this in over here. 2x minus 3 times -2 equals 8, gives me 2x plus 6 equals 8. And that means that 2x equals 2, which means X equals 1. All right. So we have 3 points to make that line. Here's 4, 0. 7, 2 is up here. And 1, -2 is down here. All right. Now, let's see. In this section, it is very, very, very important to make your lines as straight as you possibly can. So when you're doing this on paper, you should use a ruler or some other kind of straight edge. I am looking around where I'm sitting for something that would make a good straight edge. I'm going to grab this magazine, which has a nice hard binding on it. I have been a little hit or miss about drawing lines with the straight edge, and that's because if you've ever used a stylus, you know that it's kind of thick, all right? So I'm going to try that again. Put this a little further back. Okay. Yeah, that's much better. I think that'll work. All right, so now we have to graph the other line. And for the other line, I'm going to use the intercepts method. So now we're talking about x minus 2y equals 6. So for the intercepts method, I just need to know what's the x-intercept, what's the y-intercept. So remember, the x-intercept is where y is 0. And when I put y equals 0, darn it, I get x minus 2 times 0 equals 6, which means x equals 6. And for the y-intercept, I put x equals 0. And that gives me 0 minus 2y equals 6, which means y equals negative 3. I divided both sides by negative 2. Okay, I'm going to live dangerously and do that just using 2 points. Right? It's usually not recommended. Okay, so here's 6, 0. And here is 0, 3. And again, I want to draw this line as carefully as I possibly can. I think I'm starting to get the hang of where to place the straight edge. Back just a little bit. Nope, a little bit more. I'll get the hang of this at some point. Okay, that will work. All right. So what I want to point out to you, in the official part of the example, we found that negative 2, negative 4 was a solution to the system of linear equations. Let's find that point now on our graph. Negative 2, negative 4 is right here. And lo and behold, that is where the two lines intersect. It is the only point where they intersect, right? Because as you move away from that point, the lines move further and further apart. So the moral of the story is written in the presentation, right? And it is that the solution of the system of linear equations includes all points where the lines intersect. So in order to use this method, solving systems of linear equations by graphing, I'm going to give you 2 equations, and you need to graph those 2 equations and then find the point where the 2 lines intersect. So that's what's going to happen in the next several examples. And since I've got them all written on the tablet, I think for most of the rest of this video, I'll just be staying on the tablet. The directions in every problem will be solved by graphing. All right, so let's go over to the tablet. All right, so the first system we're going to solve by graphing is y equals negative 3x and 2x minus y equals negative 5. And I'm going to color code these in case that's helpful. All right, since y equals negative 3x is written in slope-intercept form, I am going to graph that one using the y-intercept and the slope. Notice the y-intercept is 0, or 0, 0. And the slope is negative 3, which I'll think of as negative 3 over 1. So that means rise negative 3, and run 1. All right, so let's try this again with my straight edge. I tell you, my perfectionist tendencies tend to come out big time. And hey, that might be the best one I've done yet. All right. Okay, and then 2x minus y equals -5. I'm going to do that one the same way using the slope and y-intercept. Notice that I need to put it in slope-intercept form. And I will do that by subtracting 2x from both sides, which gives me -y equals -2x minus 5. And then I need that negative sign off the y, so I'll divide everybody by -1, and that will give me y equals 2x plus 5. So the y-intercept is 5, 0, 5. All right, now we're in a situation that I've been hoping would come up at some point. Normally, I would think of the slope as 2 over 1, rise 2, run 1. If I rise 2, I'm going to end up off the grid. So I want to point out to you that 2 over 1 can also be thought of as -2 over -1, which means that I can also rise -2 and run -1. And lo and behold, I think we have found the point of intersection, but I will draw the line to make it official. Oh, shoot. Oh, okay. I got to try that again. Got my finger in the way. Okay, that looks pretty good. It's not perfect, but it'll work. All right, so I'm pretty sure that the point of intersection is -1, -3. Now, throughout this chapter, I am going to encourage you to check these solution points by plugging them into both equations. If you're solving the system by graphing, that is super, super important, okay? So I'm going to do that now. I'm just thinking that I may not do it in every single problem just because it will take up a lot of time. But I will at least remind you in every problem that it should be done. Okay, so if we put a question mark here, -3 blank equals blank, put in -1 for x and negative, wait a minute. Oh, wait, I'm sorry. That's not -1, -3. That is 1, 3. All right. Okay. I don't know why I said that was -1, -3. Doing the check. See why it's such a good idea to do the check? That was just a dumb typo, but I might have put in the answer -1, -3 if I hadn't checked it. Anyway, that does work. And then 2x minus y equals -5. I put in -1 for x and 3 for y this time. And sure enough, -2 minus 3 does equal -5. All right, so that is the solution. All right, next example. We're going to solve this system by graphing. X minus y equals 1 and y equals -3x minus 5. X minus y equals 1 is written in standard form. I will graph that one using the intercepts. I want to emphasize that, you know, the method that I use to graph the line, you can do it differently. It really doesn't matter. Okay. So when x equals 0, we get 0 minus y equals 1, which means -y equals 1, which means y equals -1. And when y equals 0, we have x minus 0 equals 1, which means x equals 1. So this line passes through the point 0, -1, and 1, 0. Here's a tip about drawing lines on paper. When the points are kind of close together, like these are, it is a good idea to plot another point because when the points are very close together, it's easy for your line to get thrown off a little. So I'm going to put another point here. And then when I put my straight edge down, I would like to think I'm getting better at this. That's pretty good. Okay, and then y equals -3x minus 5. That is written in slope-intercept form, so I will use the slope and y-intercept. And this is another good example of if I thought of the slope as -3/1, the first thing I would do is have to go down 3, and that would put me off the grid. So instead of thinking of this as -3/1, I'm going to think of it as 3/-1. And I'm going to go up 3 and then 1 to the left. And son of a gun, I think I have found my point of intersection again. All right. Whoopsie. Okay. So this line looks something like this. And it looks to me like the point of intersection is -1, -2. And I will remind you to check that. I won't actually do the check this time, just so the video is not too long. All right, next example, we're going to solve the system by graphing. Y plus 2x equals 5, and 4x equals 2 minus 2y. Now, I just thought of a possible shortcut. Oh, look at that. Oh, never mind. Okay. I thought maybe in a previous example we had graphed an equation that was the same as this first equation, close, but not quite. All right. So, well, okay. So I'm going to take y plus 2x equals 5, and I'm going to write it in slope-intercept form, which will give me y equals -2x plus 5. That has a y-intercept at 0, 5. And a slope of -2/1. So I will rise -2 and run 1. And let's do that one more time. Why not? All right. So this line is going to look something like this. All right, now 4x equals 2 minus 2y. That's written in kind of a strange form. Let's see what happens when we write that one in slope-intercept form. I'll start by subtracting 2 on both sides, which is going to give me -2y. Oh yeah, this will be okay. Equals 4x minus 2. And then when I divide everybody by -2, I end up with y equals -2x plus 1. So that has a y-intercept at 0, 1, and a slope of -2, which I will again think of as -2/1. So rise -2, run 1. Rise -2, run 1. we might be able to see what's going to happen in this problem. Okay, well, that's not perfect, but it really doesn't matter for this problem. These two lines are parallel, which means they're going to have how many points of intersection? They're not going to have any. So since there is no point that lies on both of these lines, that means that there is no solution. And this situation is kind of hard to check. Obviously, there's no point that I can plug in to see if that's correct. So, you know, maybe the thing to do is just go back and check your work and make sure that you calculated the or graphed the lines correctly. All right, next example. X minus 2y equals -6. Negative 2x plus 4y equals 12. These are both written in standard form, so I think I will use the intercepts, starting with x minus 2y equals -6. When x is 0, you get negative 2y equals -6, which means y is 3. I hope it's okay that I'm doing these a little faster now. I should be getting better and better at this. When y is 0, I'm just left with x equals -6. All right, so here is my x-intercept. Here is my y-intercept. Draw a line through those 2 points, which looks something like this. All right, and then we have negative 2x plus 4y equals 12. And if I do that one using intercepts, when x is 0, I get 4y equals 12, which means y equals 3. And when y is 0, I get negative 2x equals 12, which means x is -6. Well, that looks familiar. Oh, same x-intercept, same y-intercept. That is the same exact line, right? So how many points are on both of those lines? Well, a whole bunch, all right? Now, in this chapter, you have to be careful. The chapter 2 version of this was when we had one equation and we, ended up with something like 1 equals 1. And the way that we wrote the answer was all real numbers. Do not write all real numbers in this situation because the solutions are ordered pairs. They're not real numbers. And it's not all of them, right? I mean, there's a whole bunch of ordered pairs all over this graph. The only ordered pairs that are solutions to this system are the ones that are on this line. So the most general answer you can give that is still correct is infinitely many solutions. In some courses, we want you to be a little more specific than that, but in this course, infinitely many solutions is just fine. All right, so now I think we go back to the presentation because we are almost finished. Actually, before we go back to the presentation, I know the question that I'm going to ask you first. So we've seen a few different situations here. In the first several examples, the lines intersected in one point. Think about the slopes of these lines, all right? So these two lines have different slopes. They must have different slopes because they're not parallel. So those two have different slopes. These two have different slopes. These two have different slopes. It wasn't until we got to this example that the two lines had the same slope. And in that case, there was no solution because they were different lines that were parallel. These two lines also have the same slope because they are the exact same line. All right, so if the two lines have the same slope, that could mean that there's no solution, or it could mean that there's infinitely many solutions. So now let's go back to the presentation. All right, we've looked at the previous examples. Okay, so how many solutions will a system have if the lines have different slopes? The answer is 1, because in that case, the lines will always intersect in one point. How many solutions will a system have if the lines have the same slope? Well, there are 2 possible answers, either no solutions or infinitely many. All right, so those are kind of 2 extremes. So then the next question is, what additional information will help us determine which of those it is? Is it no solution, or is it infinitely many solutions? Well, you just need to know, are they distinct lines that are parallel, or are they the same line? So one way to figure that out is just to see whether the 2 lines have the same y-intercept. If the lines have the same slope and the same y-intercept, they have to be the same line. If they have the same slope and different y-intercepts, then they have to be parallel. And in that case, there won't be any solutions. Okay. So the last thing I'm going to show you is that if the only thing you need to know is how many solutions does the system have, then you don't have to graph the lines. You can just look at the slopes and possibly at the y-intercepts. So we'll go back to the tablet, we'll do this example, and that'll do it for this section. All right, so the first question is, are the lines identical, parallel, or intersecting in a single point? I got a little lazy here. And then based on that answer, we can determine how many solutions does the system have. Okay, so in letter A, 3x plus y equals 0. If I write that in slope-intercept form, I get y equals negative 3x. So the slope is negative 3. I'm going to call that M1 for first slope. And then 2y equals negative 6x. Divide both sides by 2, you get y equals negative 3x. That is not only the same slope, but those are the same equation. Okay, so this is another one of those cases where the 2 lines are exactly the same. So the answer we're looking for here is that these 2 lines are identical, and the number of solutions is infinitely many. Those 2 answers always have to go together. If the lines are identical, then that means infinitely many solutions. All right, and then this example, letter B, 2y equals x plus 2. If I divide everybody by 2, I get y equals, now it's very helpful to remember that x over 2 means the same thing as 1/2 x. So this slope is 1/2. The slope of the other line is, subtracting 2x from both sides, negative 2, right? Okay, I could ask you an extra credit question about this, about these 2 lines. The answer to their question is, because the slopes are different, these are intersecting in one point, and the number of solutions is 1. The extra credit question is, Is there anything more specific you can say about these two lines? I'll leave it very vague like that. All right, look at these slopes, 1/2 and -2. Does that remind you of anything? These lines happen to be perpendicular, okay? Not super important for answering this question, but that's why it's extra credit. All right. Okay, and that's going to do it for 4.1. We'll see you next time.